we're going to look at next for part 2 is what's called the ambiguous case. Now, from geometry, you learned of a special another triangle called side-side angle. Basically, what that meant is if you draw a right triangle and you're given two sides and a non-included angle, like this. Now, with side-side angle, we get what's called the ambiguous case. What that basically means is we can have more than one answer, or we can have no answers depending on how we solve it. Now, we're going to deal today with how we get one or two different answers, and this comes from when we draw our triangle. A, B, C. We have little a, little b, little c. We get the number of answers comparing the sides, as long as we know an angle. If we know angle A, the rule says this: we get one answer if A is greater than or equal to B. Side A is greater than or equal to B. We get two answers if A is less than B. Now, you will know when you get no answers, because when you try to solve it, you're going to get an undefined. So don't worry about that. Okay? Now, we're going to take a look at number 1 with you, and then let you guys do number 2 on your own. So I'm going to start off with drawing my triangle. Here's my triangle. A, B, C, 56 degrees. Little a is 9, little b is 10. I don't know little c. Now, first of all, I got to determine, what am I going to use? Take a look. I got side, side, and an unincluded angle. So therefore, yes, this is ambiguous. It's still a law of signs, but means we have the possibility of getting more than one answer. So I can compare A and B. Well, A is 9, B is 10. It's less than. A is less than B, so we get two answers. Okay, so we're going to get two answers for this one. And we're going to use this whole space right here for this question right here, so be ready to write. So let's deal with just one of our answers for right now. We'll call this case 1. Okay, find out what we need. We started the same way. We need angle B, we need angle C, and we need little c. Okay, that's what we need. Now, unlike the other one that we've done, we just can't simply find one of our angles. So we have to find one of our angles first. And I think angle B is going to be the easier one to find because we know its opposite side. So using the law of sines, we take the sine of B over 10, and that's going to be equal to what we know, the sine of A, which is 56 over 9. And I'm going to cross multiply. 9 sine of B equals, and if I cross multiply here, what is 10 times the sine of 56? I get 8.29. Therefore, the sine of B is going to be, divide that by 9. Well, let me just might as well use what I'm using. 8.29 divided by 9. I get 0.921. Use inverses. So angle B, take the second sine of 0.921. And I get about 67 degrees. Let's go around to the nearest whole degree. 67 degrees. So there's angle B, 67 degrees. Now, once I have B, can we then find C? Yeah, because now I have my two angles. So to get angle C, I'm going to take 180 minus the 56 minus the 67. So angle C, take 180 minus the 56 minus the 67, and we get 57 degrees. And now how do we find little c? Well, to get little c, I have to use my law of sines again. So using my law of sines, I'll take what I know. The sine of 56 over 9 equals, this is just like we did before, the sine of 57 over c. Cross multiply, I get c times the sine of 56 equals, what is 9 times the sine of 57? It's 7.548, and if I divide, I take that 7.548, I divide that by the sine of 56. and I get 9.105. And there's our answers. Now, remember, this was ambiguous. These don't occur that much. So what we have to do now, we have to take a look at case 2. Because we're getting 2 answers. Now, how we get the second case is very simple. We're still looking for angle B. We're still looking for angle C. We're still looking for little c. Okay? But this time what happens is it's what we did to get angle B. Remember, angle B was 67 degrees. To get the second angle, we have to remember reference angles. So, for angle B, we have to recall reference angles. There are 2 angles that are equal to 67 degrees. We have a 67 degree in the first quadrant, which we just found, and we have the 67 degrees in the second quadrant. So to get angle B, what we're going to do, we're going to use this we're going to get the second quadrant angle. And to get that, we should remember it's going to be 180 minus 67. And that's our other angle B. So I just take 180 minus 67, and we get 113 degrees. So this is 113 degrees. So if I draw my picture again, not perfectly to scale, A, B, C. B is now 113. Remember, A is still 56, and this is still 9. And now we can get our angle C right down here below. Angle C. So to get angle C, it's going to be 180 minus 56 minus 113. Minus 56 minus 113, and I get 11 degrees. Not a very big angle. And now we have to find, remember we had B, we had little b also, 10. There we go. Sorry, I forgot to put my 10 down there. And now all we have to do is find little c. Now little c, we do have to use our law of sines. So we're going to take the sine of what we know, 56 over 9, equal to the sine of 11 over c. So to get c, cross multiply. C times the sine of 56 equals, cross multiply here. We get sine of 11 times 9. I get 1.717 and divide it. We take that, 1.717, divide that by the sine of 56, and we get 2.07. And that was 11. And there's our answers right there. Last trick, we're going to take a look at one method to find area of a triangle using sines. Now there's another way we're going to talk about later on using what we call Heron's formula, or Hero's formula. Now, to find the area of an oblique triangle, again, this is not 90 degrees. Otherwise, we just use 1/2 base times height. We're going to use this little formula right here. 1/2 BC times the sine of A. Again, it's going to come from our triangle. In other words, it's going to be 1/2 the product of the two sides times the sine of the angle between them. And if we take a look at number 1 here, if we draw out our triangle again, we have A, B, C. This is just a formula. There's 14 degrees. A is 5, B is 9. So we have our angle. We have our two sides and the in-between angle, which is what this is. This is side, angle, side. So I'm going to use my little rule here to find the area. It says 1/2 the product, 5 times 9 times the sine of the angle between them, 14 degrees. And if we multiply all of this out on our calculator, we get 1/2, let's just do 0.5, a little bit easier. 1/2 times 5 times 9 times the sine of 14. Hit enter, and we get this area of 5 6.443 units squared. What I would like you to do tonight is to do question number 2, the same idea. Now, the one thing I do want to mention is, does this match our normal formula? A equals 1/2 base times height. And the answer to that is yes. And the reason for that is very simple. Imagine you have this angle right here. A, B, C, where C is 90 degrees. If this was 9 and this was 5, my rule would be very simple. 1/2, using our new rule, 5 times 9 times the sine of 90. Well, the sine of 90 is just 1, which becomes 1/2 our base, which is 9 in this case, and our height, which is 5. So we get our base times our height. So this formula does match with our normal area of a triangle. It's just now we can do it for any angle rather than just a 90-degree angle. So finish up number 2 here, and we're going to work on some of these problems for the next 2 days in class. Thank you.